Stormwater is our term for rain and surface runoff that comes across our site. And it's important to manage the stormwater because water can be highly damaging to both buildings and landscapes. So we control and direct its flow, and we also want to control where it collects. There's a great quote from your book here. It says, one of the goals of landscape grading is to manage and direct rain and surface flowing water to eliminate or minimize the damage and calamities caused by uncontrolled water. So then our goal is to redirect the surface water flow from anywhere the water isn't wanted to other locations on the site. Right? And we do this in order to solve drainage problems and to prevent surface erosion. There's an image right here from your textbook of some slope erosion next to a parking lot, right, where too much of the stormwater has been directed. We also want to keep sustainable design and best water management practices in mind. The old way of thinking, maybe 50 years ago, all right, was to get water off your site as fast as possible, right? Now we know that it's actually better to maintain the water on site. And we're going to use some retention ponds, water gardens, other tools that I'll teach you later in this module, all right, to do so. We store the water for later use, and we also slow down that surface water, right, in order to allow it to absorb into the ground and recharge some underground aquifers. So in our pursuit of directing water away from where we don't want it and towards where we do want it, right, your main tool is called contour grading. Right? And your text says one of the simplest and most direct ways of directing water away from a building is to elevate that structure, right, and its surrounding area, and then create a slope that will direct surface water to drain away. Right? And we want to make sure that it drains away to an area that's designed to receive that excess water. So here's an example of it from the illustration of your textbook. And this building is set on a high ground and the surrounding pavement will slope away. And you've seen us do similar grading examples, right, with cut and fill in last week's module. You already know that water runs downhill, all right? It's gravity fed. And we've talked about how it runs perpendicular to contour lines. Let's take a closer look using these examples from your textbook. Right? On the left-hand side, we see a swale solution, all right? And you can see that the low point is right here, and then there's kind of a valley effect, right? And so the water is going to come always perpendicular to these contour lines, perpendicular, perpendicular, until it hits this lowest section here, in which it will run perpendicular to this contour line and down to the lowest spot elevation. On the right hand side, we have a parking lot solution, right? And if you take a look at this, it looks flat, but it's actually graded. So we have a high elevation over here, 102, and then it's going down 101, 100, and then up, back up. So you know that this area right in here is the lowest section of your parking lot, right? Goes back up. So any water falling over here is going to run perpendicular to your contour lines until it comes to this low point, right? And then it will run down towards your lowest spot elevation at this catch basin. Our stormwater goals were to direct the water and then collect it. To direct the water, we have drainage strategies. This includes contour grading that we just talked about, swales, catch basins, and curbs and gutters. To collect the water, we're going to use storage and absorption strategies. That includes retention ponds and detention ponds and water gardens.